Hey, my name is Gaif Bakar, and today I'm going to do the homework zero and demonstrate it. So basically, our first question is that f of x is equal to radical x squared plus 1 plus 2 to the power of x plus 4. So basically, what I did is that I decomposed the first part, which is the square root of x squared plus 1. So basically, f1 is what's inside the radical, which is x squared plus 1, and I took the entire radical, which is a radical of x, and then I did put the 2x plus 4 as together. So basically, it's f3 is equal to 2x plus 4. So basically, when you put it together, it's f of 2, which is the radical of x squared plus 1 plus f of 3, which is 2 to the power of x plus 4. The second question is that f of x is equal to cosine of x tan of x plus x plus 1 squared. So basically, there are multiple ways to do this. However, I would suggest the first way, which is basically cosine and tan. We put them together as f1, and basically we break the x plus 1 squared to two parts. The first part is what's inside the bracket, and the second part is the function, which is x squared. So basically, when we combine this, it's cosine x, it's f of 1, which is cosine x times tan of x, plus f of 2, which is x squared. What's inside the bracket is x plus 1. The third question is basically f of x is equal to the logarithm base 2 of x plus 1 over sine x plus cosine. I took the sine x plus cosine x and break them apart. So basically f1 is equal to sine x and f2 is equal to cosine of x. F of 3, there are multiple ways to do this. However, I took it as an entire function, which is logarithm base 2 x plus 1. And we can rewrite it again as f functions. The fourth question is that basically we have 2 times e to the cosine x plus 1 plus pi over tan of x. I took f of 1 is e to the x, which is the exponential function, f of 2, which is the cosine x plus 1, and f of 3 is tan x. And basically I combined them to, as you can see here, this part. The fifth one is actually decompose the domains of the piecewise functions and graph the following functions. So basically we have this piecewise function. The domain is from negative 2 to 1 and from 2 to 4. And basically when we want to graph it, as you can see here, because the domain starts at negative 2 from negative 2 to 1, and that's a linear function, which is x. And basically at 1, it's an open bracket, so there's a circle there, so it's not continuous. And then from 2 to 4, it's actually a quadratic function, and we draw the part of it. The sixth question is actually we have, as long as x is less than 3, we need to draw a straight line of 1. And from 3 to 4, we need to graph the cosine function. If we want to decompose the domain, it's from negative infinity to 3, which is a 1. And then from 3 to 4 is a cosine. And this is the graph of the function. The seventh question is actually find the following limits. I use the direct substitution. So basically we plug the 1 e to the x plus x squared plus x minus 1. I plugged 1 to each single one of them, and I came out with e plus 1. The eighth one is actually the limit as x approaches negative 1. I also use direct substitution, since actually the denominator does not equal 0, because negative 1 plus 2 is 1. So basically it's a 0 over 1, which is equal to 0. The ninth question is actually the limit as x approaches 0 of e to the x plus 1 over cosine of x plus 1. And I use also direct substitution, because basically if I plug 0 to the cosine of 0 plus 1, it does not equal 0. So basically I can use direct substitution. So it's e to the 0, which is 1 plus 1, over cosine of 0, which is 1 plus 1. So it's 2 over 2, which equals to 1. And the final question, it's actually here. Basically, it's the limit as x approaches 2 of the logarithm base 2 of x squared minus 4 over x minus 2. So basically, if we try to plug the 2 in the function here, it will give us 0 over 0. So basically, that's undefined. So we need to find a way around it to actually make the denominator not equal to 0. So basically what I did was factor out the x squared minus 4 to x minus 2 and x plus 2, crossed out the x minus 2 together, and basically I have here left is the limit as x approaches 2 of logarithm 2 of x plus 2, And right now, all I need to do is do direct substitution. So basically, it ends with a logarithm of 2 to the 4. And if we want to solve it actually, x equals 2 because 2 to the x is equal 4 and x equals 2. And that's it for my demonstration for the orientation model. Thank you.